Well, hello everyone, and thank you for joining us on this webinar that I hope you all will enjoy and learn something from it. I'm your speaker, Wadi Bargash, the Hybris practice lead here at Royal Cyber. I've been a technical lead as well as solution architect for several global implementations, and in this session, I would like to share with you some of my learnings throughout the last 8 years of delivering successful Hybris project. So with that, we're going to get started to the agenda. So today we'll cover why do we need to care about performance? What does actually performance mean? And how can we measure it? How can we tackle performance before it is an issue? What are some performance tuning techniques? And then a quick introduction to our practice and capabilities. And as you know, this topic is the topic that we know we have to have that discussion, and we tend to ignore it for a bit till it's sometimes too late. So in this session, we will try to highlight how you can think about this performance and how you should avoid getting trapped into some of our lessons. So, performance overview. Why should we care? As you know, page speed is increasingly important for website. If you're looking for a page load time benchmark for your site, here it is. Users expect pages to load in 2 seconds. After 3 seconds, up to 40% of users will abandon your site. Moreover, 85% of mobile users expect sites to load at least as faster than sites on their desktop. As you design and build your website, you should, and as you examine your existing site, how are you stacking up against these expectations? Akamai also reported that 75% of online shoppers who experience an issue such as site freezing, crashing, taking too long to load, or having a convoluted checkout process will not buy from that site. And Gomez studied online shoppers' behavior and found that 88% of online consumers are less likely to return to a site after a bad experience. The same study found that at peak times, more than 75% of online consumers left for a competitor site rather than suffer the delays. So when your business or your client comes to you and says, hey, we are concerned by the performance, it is a real issue, because you will see that the search engines will rank you or rank the site based on the performance. So those concerns are valid. So also make sure that you know who are your client competitors and how your performance are against their website performance. Who should care? Is it only the business, or is it only the technical team? Actually, not only it's about the human who should care, it's in the code you will see how are we caring about for performance. Every single line of code impacts the performance of the application. And some lines are more than the others. But understanding the impact some code will have on performance should be a part of every commit. And it is also every team member's responsibility to manage performance, not just the architect or the function lead who's getting the requirement that needs to push back, but it should be part of everybody, including the business if you give them the context. Performance engineering should be incorporated as integral part of the project. Now, to when? When should we care? At the end of the project? Start? Middle? Well, the common problem is that performance is considered too late in the project lifecycle, often prior to the go live. At this point, there is typically limited time and resources available to focus on this important area. So if you have gone through an implementation, and I've gone through a bunch of them, you will see that sometimes the priority is to get to that launch date and push to production and get the site live. Now, we let go of certain things, but performance, if we let go of performance, if you have an existing site and you're going to be measured against the existing site, your orders, volume, and traffic may be hit. Your ranking in Google may be hit. So many things that your business impact, and your ROI will be deferred. So if your return of investment is within the 2 years, now you're talking about 3 to 5 years if the expected volume and business have decreased. So performance metrics should be determined to establish system effectiveness and when efficiently developed or deployed. So again, as a rule of thumb, not before the go live. So make sure your project plan accounts for performance testing phase, either as part of the sprint or stand-alone phase. Have the environment and data ready and create a dependency on them. So a lot of times we want to run performance tests, but there is no data. There is no environment to run. So the team is standby trying to get a place on the line to run those performance tests. Make sure monitoring tools are set up. It's not a good performance test if you cannot monitor what's going on. Validate the performance test script readiness before execution. For large project, consider involving a separate the performance engineering team, and we can talk about Royal Cyber Engineering team later on. As mentioned above, performance should be considered during requirement gathering and design phase, and it's an ongoing activity even after go live. Hopefully I didn't lose anyone yet, but it's the great topic we all love to talk about. Now, a lot of times the client came in or customer came in and said, hey, the page is slow. Well, we need to define what is slow. Sometimes slow is acceptable because we have a large load at a certain time with the low volume users. We're running all the jobs. Sometimes it's not. So we need to define those metrics. So one of the performance metrics, which is we need to find the clear targets. Response time or load time is one of the main ones. So you identify the speed at which a defined amount of traffic can be processed by the system. Response time is focused on determining how fast can the system handle requests. Upon entering any project, it is important to identify the specifics in both of the areas. I mean, the response time and the load, because they're different. So you need to be careful not to blur the lines between the two. Most projects will define some non-functional requirements, NFR, regarding performance that will mix both. For example, system should handle X amount of traffic with response time SLA of Y seconds, which is actually a combination of the both. When going through the process, it is important to understand which of these two numbers are most important. Talk to your business about that. Are you trying to achieve the volume of traffic at the cost of SLA, or achieve the SLA at the cost of the volume? Now, you need to talk about the throughput or capacity. Identify the maximum numbers of users, transactions, a system can handle before failure. It cannot be an NFR, cannot be, oh, the system always needs to handle any volume of data. We all know from technically, if there is an attack, it might bring it down. And if I'm running a load test or capacity test, I might be able to bring it down. So the throughput is about determining the volume of which your system can operate without a failure and does not typically take into account the speed of any individual operation. Now, we also need to look at what is the target for resource usage. Identify the amount of fixed resources. What is your memory, CPU, disk I/O, network? A system will utilize for a defined amount of traffic. Resource usage is typically used to determine scalability of the system. So if you're deploying in the site in China, you need to take in consideration certain things that may slow you down based on that network. So that's for your clear target. Those just some top 3 elements. Then you go into your testing methods, right? So most of you are familiar with load test, which is the most basic of tests, which takes specific number of concurrent users applied against the system in order to determine the response time of the application under the expected load. Goal is to identify what type of bottlenecks exist and in what part of the system. Test will look to verify the throughput and response time of the expected peak load for a short duration, usually 1 to 2 hours. Then you have stress tests, normally used to understand the upper limits of capacity within the system. This kind of test is done to determine the system's robustness in terms of extreme load and helps application administrator to determine if the system will perform sufficiently, if the current load goes well above the expected maximum. Then we have soak test. I like the name soak test. Usually done to determine if the system can sustain the continuous expected load. During soak test, memory utilization is monitored to detect potential leaks. Also important, but often overlooked, is performance degradation, right? So to ensure that the throughput and or response time after some long period of sustained activity are as good or better than the beginning of the test. And then you have isolation test. Isolation test typically can be performed earlier on in the cycle, reduce the number of variables in order to determine the bottlenecks, right? So you do have functionality, especially in Hybris implementation, that goes first. You have your PCM, your search, your indexing. So you will be able to do some of the home page and the PDP page or PLP page testings, regardless of the checkout. So you can do some isolation tests. Now to another meaning for the performance, which we need to understand, which are the bottlenecks. You need to know that you are CPU bound. There is a high CPU utilization, then small increase in load equals large CPU spike. Then you also memory bound. So you'll be looking at frequent extended garbage collection. Is there a large or irregular sawtooth pattern? And then you also thread bound. Frequent extended thread wait times, IO bound, right? If you look at if you have debugged some of these long calls, you will see sometimes it's the most time spent is in the wait. Frequent extended disk IO. Again, you're waiting to write to disk. So this just gives you a highlight of what are the meaning of performance. And when you have a discussion, try to define these elements so you're clear what are your target later on. So now we're talking about, okay, I understand why I need it. I understand what I need to define. Okay, well, what do I need to go against? And I mentioned a couple of them and how. So now you can use web tools. Web tools like Firebug in Firefox, Chrome developer tools, give you a good idea about the response time for page load and breakdown of page element speed. So you can see how much the image have taken to load. You can see how much your JavaScript file have taken to load. And then you do have your monitoring tools such as Dynatrace, AppDynamic. They discover and monitor application code running on the Tomcat and provide deep visibility of how it executes throughout the JVM in production, Java Virtual Machine. This enables users to understand where the latency is spent and how system resources like CPU and memory are consumed by an application and business transaction. So these tools will give you response time for individual method calls, your garbage collection pause, if any, your CPU use for all the SAP Commerce nodes, the DB connection in use on each SAP Commerce node, the JVM heap use for all SAP Commerce, used memory on all SAP Commerce nodes, max thread in the JVM. Now, there is a trick to this, which if you have not done many implementation that includes headless or so many integrations, you might lose visibility of where the system slows down. So you will need to have this strategy and your add-ons of these monitoring tools in place in all the servers to be able to trace a transaction end-to-end. Otherwise, you will lose that end-to-end visibility. Then you can also look at Hybris Admin Console, or what I like to call the hack, which provides a view of each SAP Commerce server as well. You can see Hybris Admin Console has monitoring tab for JVM heap now and used memory, max thread. You can also look at cache, which is EHCAS with all the regions, cron jobs, the thread dump and database login, and so on and so forth. Okay, so now we know what is performance, so we can have an educated discussion with our business and our IT, our client, whatever we're talking about, and it's not just a page is slow. Now, how we even take in this whole information? Where do we start? How do we end? So design with a performance mindset. You know, when you gather in the requirement in early stages, in detail, what is the performance test scope? Sometimes we say, oh, we need to run the performance test. What does it mean? What subsystems, what interfaces, what components are in or out of scope of these tests? Again, because you need to make sure that those are tracked and monitored. So sometimes it's not monitored. You rarely can say, I'll monitor the ERP system, how long it takes in every method down. So you only can be up to maybe the order submit or the checkout or some other method that stops at certain layer. And for the user interface, UIs involved, how many concurrent users are they? Then what does the target system hardware looks like? Specify all the servers and network appliance configurations. You need to know everything, so how it looks, so you know where do you have a load balancer, 2 servers, 3 servers. That determines when you compare from environment to environment. What is the application workload mix of each system component? Example, 20% goes in login, 40% is spent on search, 30% item select, 10% checkout. And then what is the system workload mix? Is it a multiple workloads, maybe simulated in a single performance test? Example, 30% workload A, then 20% workload B, then 50% workload C. What are the time requirements for all in and back-end batch processes? Is there a specific peak? There's no nominal peak. I mean, sometimes we tend just, hey, I want the project, this cron job to run every 10 minutes. But what will that impact your users? And if it's on the same node, not the admin node, even the admin node, what does it impact your CSRs? So you gotta understand, every impact for these jobs as well. What is the maximum system resource utilization? CPU and memory when you run the load. What is the method of measurement? Is it TTFB, TTLB, TTI? And what is the measurement calculation? An average, 98th percentile, 95th percentile? So there is so many things you need to gather during the requirement to be able to run a good performance test. And while you're gathering the requirement, there is this notion, I know such a thing as a free lunch, right? So remember, that is not always about how cool something looks. It's about how smooth it functions and feels. You can use different techniques. I can go through one example with your business partners to balance between UX and performance. But it cannot be all taken without performance consideration. I want a search page that has pricing, stock, dynamic cross-sell and upsell, all my imagery and every bit and whistle, and my promotions in one page. And my page size for the search is 100 product. So you gotta be reasonable with that. So an example would be put a large hero image at the top of every page. That's how the business may put it. Then the UX consideration, this is why they want an eye-catching to represent the brand well. So in the performance, hold on, this will be a large file that will hinder the page speed. So we can discuss, we can give you the why you want an eye-catching to present the brand. We can make sure that few colors are used in the hero image and it's compressed correctly. All right, now to the third point. While you're getting to that performance mindset, is identify the potential problems area. Better the devil you know than the devil you don't, right? So, and you can get a gut feeling during these discussions and requirements gathering that this is gonna be an issue. So during the design phase, identify areas of the design that require more focus and attention. Incorporate an isolation performance test, as we talked earlier about it, using JMeter or Gatlin, and do a POC. So functionality to look out that could be, when you're going through that, high volume transaction that will see lots of hits, especially with a lot of concurrency. Large data transaction that require processing of a lot of data, especially in a synchronous fashion. Again, a lot of integrations. This service called this service, and then the other service, and come back and I call tomorrow. So look at those transactions, right? And heavily custom transactions that are extremely unique to the client business and require a lot of custom Java code. So this is where I will put my disclaimer here, and I've seen it throughout all the years. SAP Commerce Cloud, it is a performance tool, and I don't work for SAP, but if it's customized in the wrong way, it will give you performance nightmares. So that's why you will see at the end, we have certain best practices we like to keep in mind very early in the stages. Then on to the fourth point, it's an iterative performance development. So Isaac Asimov said that your assumptions are your windows on the world. Scrub them off every once in a while, or the light won't come in. So consistently reevaluate the assumptions behind the design and modify the solution when they change. So don't be afraid to refactor if the solution does not fit the need. And this is over and over. Some architect will be stubborn and say, no, this is gonna work. But if it's not working, find alternatives. It's okay. There's other solutions to solve the same problem. And do an iterative testing as well. Understand the trade-offs of every change. So don't change 10 things at the same time. It's change one thing at a time and involve tests, analyze the result, apply a change, repeat as much as necessary. So if I apply 10 changes, all of them, 9 of them give me 1 + 1 second, and 1 of them give me -2 seconds. If I apply all of them, then I'm at what? 9 is -2, so I'm +7. I say, oh, this is good, let's push it. But if I do one at a time, I'm +9, because I can let go to the last one that gave me -2. Okay, now let's go to performance architecture. This is where it gets a little bit more technical, right? So you need to master the basic of page speed. We talked about page speed is very important and how your customers, your website users interact with that page speed. Now you need to know as the architect or technical lead or anybody discussing this, the basic. In addition to knowing the performance targets, as we mentioned, as early as possible, you need to have a good understanding of these. How browser render the content, how the requests are handled, the perceived performance, the site infrastructure, the geography of the site users, network infrastructure of the site user, what browser do your site need to support. And I've seen this especially in the B2B client where their users are another company that all have IE, but they never thought about IE. And all the testers are doing Chrome, okay? So what is also the data volume and how your transaction volumes are in each page. The second point is you need to follow the best practices as mentioned earlier as well. Make sure your technical detail design document and implementation are built with established industry-recognized Java and Hybris best practices, right? So you need to look at Java code conventions, development anti-patterns, architecture anti-patterns, SAP Commerce, as I mentioned, best practices. And in your detail design, put performance impact in each section. Let the developer or the technical lead think about it. Optimize the data model. Create deployment table for any type that directly extends generic item, which means do not create a deployment type for any type that does not directly extend generic item. Sorry for the non-Hybris technical people, but this is purely Hybris technical terminology. And then you need to create a subtype to help filter data instead of multiple flags. Use relations to link to complex objects and avoid using collection type for anything but primitives. So you can use the many MN relation, right? Many relation to assess the object bidirectionally. Apply indexes for flex search performance. You find unique attributes and define them in items.xml. Attribute used in ware clause, put an index on top of those. So, look at your queries, see what you're running frequent, and the monitoring will help you to find the most used queries, and that will help you as well to find what better index I use. Again, there is a balance if you're using HANA or Oracle, and you gotta go through that, but that's more of an advanced level. Now to the fun topic about balancing integration strategy. You know, those architects in those meetings try to say, hey, this should be async. No, should be synchronous. I want real time. No, it shouldn't be real time. You know, there is a balance, and you need to give the context to your business, and you need to have also some kind of experience behind it of how most successful implementation are. As the system integrations tend to take longer time to return response, the service integration should be designed to support reasonable usability. There are two types of integration, as I mentioned, sync and async, synchronous and asynchronous. The advantage of using synchronous integration is that the client knows the status of integration in a very short time. The disadvantage is that the user session is tied up, and it limits the capacity of the server handling the large number of these requests. So if I'm a customer trying to place order and your order are waiting for the ERP system to come back with a response, now you're holding my whole order confirmation for something that maybe can be done later on, and it never fails. So the advantage of using asynchronous integration, on the other hand, is the flexibility and the higher availability. But the disadvantages are they can lack of sense of immediacy and the complexity, including data not being received on the server side. So I have a couple of rules that I like to do. Any data integration should be implemented as async integration. This includes but not limited to all data feeds, import, export to third-party application. If you have master data for product, bring it as async, please. The batch data processing like fulfillment or return order data, also, there's no critical thing about not having those in a batch mode. Again, a batch mode does not mean every day or every week. It can be every hour. That's still gonna be way better. Integration supporting the user interaction sessions should be implemented as sync integration, like recommendation, taxation, and payment processing. If specific integration experience performance issues, async integration could be potentially applied, and notification could be sent to the user when the integration is finished. I'll give you an example. In the B2B scenarios, sometimes the order processing from the backend may take some time, so you can respond to the customer with, hey, your order has been received. A status will be sent to you. This is your order number. And then you balance your caching strategy as well. This is where you take a page and you try to say, hey, I can have this data coming from Solar, I can have this data coming from EHCache, I can have this data coming from my Akamai, I can have this data coming from, I need to have this data coming real time from the backend system. So look at your page and try to categorize your data. And then you can even say, okay, well, you want this data real time, why don't we use lazy loading and add Ajax? Or then when you click on it, and you click on the drop down, that's when I'm gonna get you the data. So I'm gonna put an on-demand data. Okay. Performance tuning techniques. This is gonna get a little bit more technical as we go. So hopefully folks are enjoying this. So performance tuning definition. Again, now we talk about why we need it. Then we talked about what metrics. Then how we're going to do it, and the methodology is it's early or late. Now we get into things are not looking well. What do we do, right? So for any application or platform, the amount of resources are limited due to a number of reasons, right? You're not going to have unlimited budget to buy all the infrastructure you need, or you have an organization flexibility. There is always something in there that will be your resources, and they will be limited. So performance tuning is the improvement of the system performance. It's not basically improving your resource. That's a little bit of cheat sheet. So performance problem can be real when we have, of course, the matrix available. Otherwise, we're just guessing. Or anticipated, when we have a peak seasonal load for commerce site, tax filing days for tax preparing site, right? So we can anticipate certain performance problems. Modifying the system to handle a higher load, called scalability, is synonym with performance tuning. For any system, the performance decreases with load increase. So you need to measure, evaluate, improve, learn, and then cycle back again. So assess the problem, see what is going on, look at your monitoring, and establish metrics that categorize acceptable behavior. Say, okay, well, I'm at 5 seconds in this page, the normal is 3 seconds. Then you measure the performance for the system before modification. So you have that 5 seconds now. Identify the part of the system that is critical for improving the performance. This is called the bottleneck. So, okay, I look at the page, I think my stock is the one that takes more time. So that's my bottleneck. Modify that part of the system to remove the bottleneck. So let's say we'll look at it, oh, I don't need to get all the variant stock. Let me just get this SKU stock, right? So one change, again, don't make multiple changes. You're in a very hard time to find which one made the difference. And then measure the performance again after you fix of the system. So if it's good, fine. We find the issue, we solved it. If it's not, let's do it again. If it works bad, let's roll back. That didn't help. So you have your performance levers, right? There is no silver bullet in performance. Sorry, folks who joined here to find the silver bullet. There is none. But there is multiple things you can do to improve it. Some of them may be higher than the other. So you can look at your technical configuration. How underlying hardware is, for example, load balanced or set up for failure, how app server is configured for high load. You can look at your application code. Is application code making unnecessary calls to external system? Whether database tables are indexed or normalized properly. You look at the code that's been developed by developers for a long time and different developers in and out. You will see redundancy in everyone building their own method to call the same thing. You will see a method that you already have data but did not delegate that response to the next call. That's just typical things. So look at your calls and see if what are you making, or can you leverage a previous call in the same transaction. Then you have your functional configuration. How complicated is your workflow? Whether the customization has some performance side effects to meet the business requirements. Again, there's always place in the process, the functional processes, to improve. How the system is used, whether the request load is heavy every day or occasionally, how much data and what frequency is fed to the system every day, whether the system is designed to take that load or there need to be change in the processes, right? And I've seen this before where our expected user and order volume, our order volume was expected to be 1,000 orders per hour, but then after a month, we were hitting the 10,000 orders per hour. So the system was never scaled to handle that or tested to handle it. So now you gotta be acting quickly to manage the extra load. And then you did data profile, right? How much data need to be handled by the database? Can historical be archived? I've seen systems where the data for 20 years is still there. Jobs that ran 10 years ago still there. Why do we need them? Nobody's looking at them. So challenge that. External integration impact. How dependent is the system on external system response? Whether the response can be cached to handle outages failure. You have read some of my blog, some big component of microservices and API gateway, and it adds a nice caching feature in there. So look at that. Look, how can you break down your system? How can you run your calls in parallel instead of sequence them? Okay, it's getting more technical. So performance tuning areas, right? So I'm gonna start with the application server or configuration tuning. There are so many parameters we can fine tune, but I'm gonna give you just a couple, and it might be a hint for you to give us a call. We can go through this in detail later on. But here you go, get your pen and paper ready. Let's start writing some of these. So there is Tomcat parameters defined in the web XML. There's a parameter called session timeout, right? You can make it equal to your default session timeout. There is Hybris init filter, right? So in that one, you can enable compression and you can make it false. And then there is context parameter. And I think you can see the tag pool max size as well. Should be set something to 50. And then there is Tomcat also parameters, but it's defined in the local properties. So that's your Tomcat max threads, and then your Tomcat development mode. Make sure if you're in production that this development mode is equals to false. I've seen it before when we came in to help with the project. Then you have your Java virtual machine settings. You should use G1 GC garbage collector, and then look at your minimum and maximum perm size, your JVM heap setting, your garbage collection login. All that impacts performance, so try to tune it. Try to disable the add-on filter. And then I think there's a property called add-on filter that's active, set it to false. SAP Commerce backend processes, right? Those impacts. So there is, you can put impacts importer workers in there, set it up so it can help you when you import in impacts. There's catalog sync workers also for your catalog sync. Accelerator services, that batch that impacts that max thread will help you increase the thread of your batch processing for these impacts. Then there is a distributed impacts that was introduced later on. So for large volume and complex external files, you should utilize all the nodes in the cluster as well. And some scripting within the impacts file, make sure that it's not there because it's not supported in the distributed impacts. Then you have your web server tuning. So you see, no silver bullet still. So look at your AGP, the web app connector. So does the binary base reduce the message size? And then look at your Apache NPM multiprocessors modules, right? I think the work or event module helps with multiprocessing and multi-thread. Apache modules only enable modules that are needed for your Apache. You also have Apache Max request workers and Max client. Make sure it's not too high or too low. Then Apache start servers, min spare servers, and max spare servers parameters. There is a rule there. Start servers equals max client equals thread per child. And then the min spare server equals max spare servers equals max client. Access configuration as well. So this is your HTTPD config. It's preferred over the HT access. And you can disable the use of it. Avoid, allow, override all in Apache. All right, it's a lot of technical words, and we can provide you with the detail of all the settings that we have used to tune our client's website. And then you get to the cache strategy, as we talked earlier. Will depend on project technology landscape and specific implementation. And it takes several iterations to optimize the cache at different levels. So the e-commerce system should use multi-level caching strategy with caching of data at application, web server, and web browser. So you can see a lot of details on the wiki about caching, help by Hybris, or we can help you with that. But in the majority of SAP Commerce project, we have used the tier caching, item data query, and DTO caching. We used HTTP caching, we used Apigee, that's the API gateway, and we used the CDN for tier caching, like Akamai. And then, of course, we use the browser caching with using the HTTP in the header. So when you cache in consideration and strategy, right, consider results that are resource intensive or slow to retrieve, likely to be reused, right? So those are the ones you need to start with. Don't just guess which one I'm going to start with. Just focus on put them in a priority so you can tackle the main ones first. Then weight potential performance benefits against potential risk of stale or incorrect information. Now, there's more that I can go through, but just to cover, there's DB tuning, right? Look at your complex queries, especially the one using union, subselect, case, or multiple left join, or that returns more than one object. Right? So tune in a full set of data. Tune both way, top and bottom up. Transactional data archiving. Remember that what I mentioned. See if the cron Job execution table is cleaned, abandoned carts, the prop table, the BTG results table, saved value tables, which save the changes. So periodically clean up these records. You don't need to keep 5 years. 1 year is max for certain things. And then look at your DB pool, right? Your max active, your max idle. And SAP works well in combination with default HANA and Oracle configuration. So no need to change these in most cases. Then we get to Solar. Solar should have proper indexing parameter for high performance indexing. This is in addition to making the slaves and the master. I usually have 2 slaves and 1 master, maybe 1 master with the slave in the same node. But look at your number of thread, the socket timeout, the filter caching, the document cache, the query result cache. And then we get to the fun part. This is where people spend time and time, but they forget about the rest, which is the front-end tuning, right? And there's basic, you can see all of these later on, but just some minimum HTTP request, use expires or cache control header, gzip component, put style sheet at the top, put script at the bottom, avoid CSS expressions. I can go on and on and on. I have a list of at least 20 here or 30, I think, element in there. But because I don't want to go over my time, we're almost hitting the 45 minutes mark. I'll get into some of introduction of who we are. So we are Royal Cyber, an SI that specializes in commerce, cloud, RPA, AI, ML, and integrations. My group specializes in commerce and especially in SAP Commerce Cloud, which is Hybris. However, we do strategy, marketing, delivery, and QA, as well as managed services across all these practices. We have 700, more than 700 employees around the globe, and we're present in almost all the regions. We have 30 clients globally, and we work throughout 12 different industries. We are 2019 Chicago Best Workplace. We're proud of that. We had a lot of fun work environment and very great team onshore and offshore. And we also are a Hybris SAP Commerce Cloud silver partner. So for the Hybris practice or the SAP Commerce Cloud practice, we have our headquarters in Chicago, where we have 30 plus employees, and then we have more than 70 people in 2 dev centers, and then 20 plus SAP certified employees. Our services. So as you can see, we have 4 pillars in our services in SAP Commerce Cloud. We work in innovative commerce implementation. We do fast upgrade and migration, and then we do performance and quality enhancement, and we also deliver quality managed services since we've been in the business since 2003. So now, in addition to our SAP Commerce practice, within that, we have a performance engineering team that's specialized in performance engineering tasks. This is usually for the large project, but our team is also equipped to run these in a smaller scope. So we run risk scope assessment, peak workload analysis and modeling, performance SLAs, NFRs, and performance budget refinement, manage virtual services, we manage performance scalability and resilience, we manage APM and fault domain isolation, and manage front-end performance test simulation. This is in addition to our normal activities, which is performance test environment management, like configuration and data that I mentioned, in addition to performance defect remediation based on what we found during these testing. So just to give you an overview again, to go a little bit of detail on the methodology that I mentioned of that cycle. So you discover and analyze, you discover an issue and you start analyzing what it is, and then you test, you figure out what is my issue and how long it takes. Then you diagnose what will be the issue. Remember those bottlenecks. Then you go tune it. And then hopefully with the next cycle, when you try to look at it and analyze it, the test will come out with a good result. Or if it's not, you try the next thing in the fix or the tuning strategy. Okay. So with that, I'd like to thank you for joining this session. That was a great pleasure sharing with you some of our knowledge. And again, if you have any questions, please reach out to us, marketing@royalcyber.com, or go to royalcyber.com and submit customer service request. Until the next webinar, thank you all. Bye.